Yeah. Hello everyone. This is day 13 of the data science bootcamp. In the last lecture, we started with machine learning. In this lecture, we will continue with the proceedings and we will get started with scikit-learn library. Before that, everybody please open your Jupyter notebook and that's how we'll get started. Give me a minute. I'll start sharing my screen. Is my screen visible?
Yes. Yes.
Did you open the Jupyter notebook, guys?
Yes. Yes.
Okay, cool. I'll share a CSV data. What we will do, we will train it today and then we will go forward from there. How easy it is to do it using scikit-learn, we'll do it. We did a small what do I say demo in scikit-learn in the last lecture, didn't we?
Yeah.
We did, right? Similarly, we'll do it. So, scikit-learn intro is something that we do. Let's do a quick revision of this. So we had features, the and label. These were the data that we gave. We used a model which was decision tree classifier, and we were able to predict. Okay. Okay. Going forward, we will move to the next uh, training. How to code. You guys will need the data. I'll share the data. Just 1 second. Mm, Okay, this is the an Excel file with the details of iris. We actually don't know what exactly uh, the data is, so we have to make sense of it. What I am making sense, this is the length of the iris, this is the width, and again, these are the petal width and petal length, and this is some class which is specified to iris. Iris is what they are talking about, I believe, is the part of an eye, if you're familiar. So what we will try to make sense out of it, we'll train this data and cool. Let's do one thing. I'll share the Excel file first. How am I going to do it? Can't share it to chat. Let me do one thing. I'll share it on WhatsApp. Would you be able to put it, take it to your system from WhatsApp?
Yeah.
Oh,
Yes.
one second. Mhm. Document. Text. Okay, this is an Excel file. We'll store it in your system. Okay, and let's first get started here. And then once we are done, we can take a look at it. Okay, we have the Excel data. First, what we are doing, we are importing the pandas library. Okay, then we are importing random forest classifier, which is our model. Okay, this is our model that we are going to use. A random forest is a meta estimator that fits a number of resident tree classifiers on subsamples of dataset using averaging to improve the predictive accuracy. So we will be using this to create our prediction model. So first, what we are doing, we will be reading through the Excel file. Do I have access? Okay, it is outside of my okay. Let me check. Iris train.xls. Hey, hello Devesh. Hmm. Now this should do it.
Hello. Hello. Am I audible?
Uh, yes, yes, you're audible. Hello Devesh, how are you?
Fine.
Why am I not able to read it? Just once again. We are not able to locate the file. This is the file which is iris training.xls. Copy path. Putting it right here. And this is inside the file name is with training on iris. Okay. 500. 500 with training on iris. It's right here, right? Hmm. So this should, I should be able to read it. This is happening. How come this is file not found? Oh, did you get it? What was the problem? It is asking us to install module. So module not found error. I missed it as file not found error. So that was the problem. I got it. Okay. Done. After we imported the library, we should be able to read it, and now we are able to read it. Okay. So what do have we have in this Excel file? We have the head, which is length, width, petal width, and this class. So head, we get the first five elements as per the what do I say? As per what we have learned in the previous lecture. So the next, what we are getting, these are the features and these are the labels. So if you take a look at the features, which is Iris Virginia's, okay, Iris Virginia's CA. These are probably class. That is what I understand. And X is the feature. So if you go to the values, these are the features. So what this exactly is doing is, can anybody help me understand what is iloc from colon to colon -1? Anybody? data from location, index location, column 2, column -1. What are exactly we doing here? I'm audible, right?
Yeah, yeah. I forgot the use of iloc. What exactly iloc does?
So we are, what do I
We
say?
are asking for all rows,
Hmm.
and that -1 means last. We don't want last column.
Yeah, exactly. We are removing the last column. So iloc location sort of like give you in array when you look into an index. So you give this. So similarly in data frames in pandas, this is how you do it. Iloc is index location. So we are getting all the rows. We are excluding one column. Yeah, that's some problem. Yeah, better. Okay. And similarly, what would be this? From column -1. Oh, that's exactly what we did. Column and -1. Yeah. So we are excluding all the rows and we are getting the we are removing the last column, which was class, as you can see here. And why did they write this both? Oh, okay, which is -1. So now we are only getting the last column. So this whole table is divided into features and label. So if you can understand, if the value is 7.9, 3.8, 6.4, and 2.0, then the class is this, which is Iris virginica. Okay. And if the value is 7.7, 2.6, 6.9, so this is the feature and this is the label. That is how it is divided. Understood? In the last lecture that
Yeah,
we saw here, we are defining features and label. If weight is 150 gram, then it is apple. If weight is 170 gram, it is apple. If weight is 130 gram, it is orange. Weight 120, it is orange. Cool. Similarly, if these four values are certain, then this it will be this class. Got it? Okay. We are using the model random forest classifier. Okay. Getting all the values of the x. Now again, similarly, model fit. Okay. We are running random classifier model. And now we are predicting. Okay, this is a predicting prediction. If let's say I think if I length width, petal length and petal width. So length width, petal length and petal width are 5.4, 3 and 4.5. Then what could be the prediction? And the prediction it does is that it is going to be iris versicolor. So what I understand from this, that from these four features, we can predict what would be the color of the iris. Got it? What would the class of the iris? Okay,
hmm,
understood?
yes.
Okay, that's one of the prediction model that we can use. I think this should be enough. I'll ask you guys to copy this. Devish, you also have that Excel file, and you can read it, and you can create this prediction model. While you're copying this, I'll prepare for the next problem. Okay, cool. I'll remove all the notebook. Uh, this should help. Got it? I'll revise it once again. We are reading the file. We are getting features and label. We are using random forest classifier model. Then we are running a fit. We are fitting the model. Then we are running a prediction, and we are getting the prediction. That's easy. That Scikit-learn is doing all of this for us. No need to write all the cells. Just understand and write the one which are needed. Do you want me to scroll down? Next, we will learn how to measure accuracy. Shall I scroll down?
Yes.
Okay, I think this should be enough. Are we done?
Yes.
Okay, cool. Let's know one thing. Okay, let's do one thing. Let's Chris, if you want to share your screen or on Nishan, I mean, Devesh won't be able to do it or else the system will die. I mean, as per historical data that we have. Nishant, if you want to share your screen, what we will do, we will run a prediction model on your system.
Actually, the O code is not working on my.
Okay, share your screen, we'll solve it.
I'm getting error there.
I mean, it's a value error. Looking for certain values which is it's not getting. Probably it's not defined. Go above. You run all of it, right? Okay. You're able to read the data, your X, your Y. You're using random forest classifier. And once you do a model fit, you're getting a value error. Probably don't have to pass value. Okay. You're trying to fit a classifier with expert discrete classifier and regression target with a continuous value. Scroll up. Oh, okay. Show me the X dot values for your output.
The
Scenario,
Y
right?
in the Y1, uh,
In the Y1 what? You call
I
hey,
was
Y is
we are
different.
using
Y
the
is
same.
different. You're putting the
Yeah,
same value.
just remove the column
So
the
no,
minus
you
one.
have to understand. In Y we are just getting the column value.
We want the last column only, and we are
Just
getting
the
the
last
same
column.
value for X and Y.
You have to understand, Nishan?
For Y, we only want last column.
Yes, we want the last column. That would be the label. Go back to your screen, I'll explain.
We want only class column.
Yes, yes, yes. That's what I told, right? The X are the features and Y's are the label. So if the value is 5.43, 4.5, 1.2, then the class is iris versicolor. Oh, that's the class. So we are dividing into feature and label. So it is only going to be column one, not even column. It's only going to minus one. That's my bad. It's only going to be minus one. You only want the last column. Okay, now run it. Now run the model fit.
Yes.
Okay, now it's running. Okay, now get the prediction, run the prediction. Print the prediction. Okay, it is iris versicolor. Okay, how do we verify it? You can go to the Excel sheet and check for the range. If it is 5.43 and put any value out of it. And then if you see it is right, then it is correct. Like scroll down and check. See, for now it is very simple. We have data, so we are able to. I think probably this has 100 what do I say rows, and you would be able to check it. 5.43, 4.5, 1.5. And that is how you, let's say, even in your test data itself, you run it through the value, you will get the accuracy. Accuracy is number of correct data divided by total number of data. So that's how we get the accuracy percentage for any model. And in our case, it is going to be 100%, I believe. Is it understood, or was I not able to make it clear?
Understood.
Understood, right? Okay. Stop sharing your screen. I'll start it again. Cool. I'm sharing my screen. So what we'll do, we'll go to accuracy now. You will understand it. Yeah, I have to sort of organize this. I mean, now it does take a lot of time to find accuracy. Yeah. Okay. How are we checking for accuracy? Same, importing the data. Okay. Again, features and everything. We are using a decision tree classifier. Okay. First, you have to understand it. How do we decide on the model? Okay. Let me show you something. That is a very good documentation. We will go together. Go through it together. How to choose an estimator. Okay, the documentation. Choosing the right estimator. Okay. Often the hardest part of solving a machine learning problem can be finding the right estimator job. Different estimators are better suited for different types of problem. It's visible, right?
Yes.
Okay. The flowchart is designed to give user a bit of rough idea how to approach the problem with regard to which estimator to try on your data. Click on any estimator in the chart to see documentation. The try next orange arrows are to be if estimator does not achieve the desired outcome. Okay, let's do this. Ah, okay. Currently, we are at classification. You know what we are doing? We want to check on the, what do I say? Let's go to the flowchart. Let's start. Okay. When the sample size of the data is more than 50, we try to get more data. So this is algorithm cheat sheet that we should be using. Okay. Are we predicting a category? In our case, we were predicting a category. Yes, we were putting it, we had predicting a category. And we also had a label data. We had a CSV where first four columns were the data and the last column was the label. Okay, we have it. And if the sample size is less than 1 lakh, which is 100K, then we use linear SVC. Okay. And we tried it. If it is a text data, then these are the classification that's being used. And if it is, let's say, if it is not greater than 100, then we use SGD classifier. Okay, then we keep on trying. So we use classification model in there. And random forest classifier is one of the classification in that random forest classifier, which is used for prediction model. Okay, that is how we came into a conclusion, like how we are using random forest classifier. Got it? Because we had a we wanted to predict our what do I say regarding our input. We also had a label data, so we are using classification. And random forest classifier is something that we came up with. Is it clear? Clear, right? Okay. Similarly, we will go ahead, we will be using clustering, decision reduction, regression. But once that come into picture, we'll use it. But the reason we use classification because we want to use prediction and hence we use classification. Okay. Let's come back to the accuracy. Decision tree classifier, we wanted to use this classifier. Again, we have all the values, pandas. We are using decision tree classifier, getting the data. Okay. What was the name again? Train data. Rename Iris train data. I run it, and now we have all the data. Add this for the checking. Four other features. Fifth is label. Similarly, we get -1 till this column. We are negating the last column and we are getting the detail. We are only getting the last column in the white. Okay, if your doubt is now cleared, Nishan, we get the classes here. Now we are using decision tree classifier. Okay, we have all the values of the x. We are doing a model fit. Okay, the classifier is running. Let's use a predict, and then we have the prediction model, and it is iris versicolor. That's the prediction model. Okay, let's go through it and understand. Okay, a random forest is a meta estimator that fits a number of decision tree classifier on various example of data set and uses averaging to improve the predictive accuracy and control over fit increase in forest uses best split strategy. I think I went a bit too fast. Okay. A random forest is a meta estimator that fits a number of decision tree classifier on various subsample of dataset and uses averaging to improve the predictive accuracy and control over fitting trees in the forest due to best split strategy. Equivalent to passing splitter equal to best to the underlying decision tree classifier. Hmm. So whenever we are using a classifier, decision tree classifier is the default. If we pass a value of splitter equal to best decision, if you go to decision tree classifier, and if you check, you can pass splitter equal to best. When you pass splitter equal to best, it automatically become random forest classifier. We'll get into the detail like how are we choosing the classifier. So the decision tree classifier is the default class, whereas random forest classifier inherits decision tree classifier and it uses a splitter which is if it is set to best, use random forest classifier. Got it? Clear, right? Okay, cool. Awesome. And hence, currently we are using decision tree classifier. And what it is happening, see how they are measuring accuracy here. You are getting actual values. They are writing a loop, okay, and it is doing a prediction. There's a prediction. We have a prediction array where it has made all the prediction. And if the actual value and the prediction equal to same, then the count is incremented by 1. Okay, if you understand that, then here we are getting 100% of accuracy. So definition of accuracy in the test model, you are using your test data to create a model, to create a prediction model. Then again, you are passing it through your test data and you're checking like if the prediction is correct or not. And then how we are defining the accuracy. Okay, any doubts here? All right, cool. Let's move to the next part. Okay, let's do this. This will be interesting. Maybe we'll ask somebody to do this. Okay, I'll share the data first. Divish, do you want to share your screen?
No, sir, I am joining with my phone.
Okay. Krish, if you can share your screen. I'll share the data first download it and then you can share your screen. It's a zip file. It has data of all the houses and we will be predicting the prices. Let me know when you download the data, folks. It's done, right? Cool. Krish, if you can share your screen. Okay. What we'll do, let's analyze the housing data that I've shared over WhatsApp. And once you can see through it, we will run the prediction model over it.
Is it visible, right?
Yeah, it is visible.
So what we have to do?
Open the CSS separately, or maybe you can import it and do a data frame dot add. Let's do it that way. Let's do it how data science it is done in data science. Data dot head. Okay. Data dot head. Do ahead. Okay. See, we have longitude, latitude, house average age, which is median age. Okay. We are calculating total number of rooms. I think it's building. It's not a house. Okay. Total number of rooms. Total number of bedrooms. That's the population. 322. Okay. It's number out of which 126 is household. Oh, okay. Okay. Got it. 126 house. That's the income. That's the house value. Okay. So we will be predicting price according all these features. Okay. Let's start with random forest. I mean, you have the previous one. Let's start with that. Import the random forest classifier.
What was the audio we
Now you can check it out in the previous notebook. Now here, what would be the first question? What would be the features and what would be the label? Do we have it?
So this all will be features except the what we have to
Value is
calculate
label, correct. Median house value is the label.
is the like
Okay, divided into features and label. Nishant, you also tried yourself on your system.
Yes, yes, I'm good.
we will be using iloc, right?
Sorry, what? Yeah, iloc. Correct.
Every so
I'm not able to understand. What did you say?
this is the first parameter is for rows, like we want all the rows.
We want all the
Next
rows.
one, next one will be the column.
Yeah, but is median house at the end of the column? Like, are you? I mean, maybe you have to check that. Try to figure it out.
-2.
So that will delete all till medium income. Ocean proximity will sort of lose by. I believe this is data of houses in California. That's a very classic problem when you learn that.
How we would get the only,
Sorry?
how should we get this all the columns except this median house value?
One thing what we can do, we can just get the median house value, set it as the label, and then delete it from the current data frame. That's one of the way to do it. Copy the data frame, get the row, get the column, my bad, and delete the column from it. So you have labels and features, two different values. Understood?
I didn't get it.
If you're not able to think of it, you can always Google and get it. The syntax and everything, we are not supposed to remember.
So first, what we have to do?
First, get the label. So y is equal to df of median income. That's it. Data. In case it's data of median income. Median house value. My bad. So instead of y, let's name it house value. That's your label. No, name it house value, or I think that's the label you want to give, right?
Yeah.
Put it in string. Okay, check the house value. Correct, that's what you have it. Now you want features. Okay, it's better to name them features and label. So house features. No, I mean, it's okay. Let's put it label. So house value would have been better, but let's put it label. Okay, house feature. House features. There are multiple features, so it is going to be plural. Now do a data of what do I say? Just copy it.
Data of
Just data.copy. So you will have copy of the data frame, but it will not refer to the previous data frame. Got it? Okay. Enter. House features is equal to, just do it house features dot pop and pop the median house value. Okay. Now check house features value. House features dot head, whatever you want to do. Do a head. Okay. That's deleted now.
Okay.
Okay. Now you can use it. Now you have features and you have label. Now you can utilize it to and pass it into the classifier and get it.
Which one we are using?
Using random forest classifier, that's the best classifier. Not the best classifier, but easy to use classifier, I would say. So to do a model.fit, right? First. Pass the values. House features. House underscore features. Now to pass the values, dot values. Values. House features dot values that you have to pass.
House
We
features
pass
Dot values.
dot
label.
values.
The values is a function. Yeah. Values will not work. And similarly for house value. Is it values or value?
We house underscore labels. We name
That's
it
house
as a
underscore
label.
label. Run it. What's the error? There's a value error. What's the value error? Scroll down. Model.feature. Scroll down. Will tell you what the error. It usually comes at the bottom. Scroll. Sparse multi-label indicator is not supported. Okay. Could not convert string to float. Okay. Nearby is something that's causing problem.
This one,
Okay.
string proximity, it's in the string.
So it does affect the pricing, right? Because if it is near the bay, which is near the ocean, then the prices would be higher. I mean, that's something. So, okay, that we have to fix. Scroll down. So this has to be, okay, let's just get me all the unique value from that column. What we'll do, we'll convert that into an integer, and we'll map that value to whatever the common values are. Let's say if it is nearby, then it will be set to 1. If it is not nearby, it will be set to 0. So we will have mathematical values.
Hmm.
Did you understand what I'm asking for?
Yes, we have to just change into zeros and one binary.
So first step is you have to get all the unique values in the ocean proximity column. That's the first step. Nishan, did you follow?
Yes, sir.
Okay.
So it has the data frame has the method, right? Something.
Sorry, come again.
Pandas is the method.
Yeah. Unique. That's it.
dd.unique.
It will be data of ocean proximity.
pd.unit and then house features. pd.unique બરાબર છે એના પછી આગળ આવશે નહીં એના આગળ આવશે house features નહીં ત્યાંની અંદર unique ની અંદર.
So just passing a string instead of that you have to pass a data frame. That's what I've been telling.
Data frame પછી એની કોલમ નું નામ આવશે ને like house features એ બરાબર છે. હવે એના તને ડેટા ફ્રેમ માંથી ઓશન પ્રોક્સિમિટી કોલમ જોઈએ છે તો તને આ ડેટા ફ્રેમ નું નામ છે હાઉસ ફીચર્સ. તો હાઉસ ફીચર્સ ઓફ ક્યાં હાઉસ ફીચર્સ.
So data in the
ડેટા ફ્રેમ નું નામ તારું હાઉસ ફીચર્સ છે. તો હાઉસ ફીચર
House features of ocean proximity. That would be a function. Do it in a square bracket.
Rectangle bracket.
Rectangle square. Now do it, you'll get to all the unique values.
Unique value.
Yeah, so Nishan, for Devesh, please speak in English.
Okay.
Or also Hindi would be good enough. So these are the values. Now replace all these values according to integers. So that's how it would work. Near b is 1. I don't know, 1, what does that mean? Less than 1h ocean is 0, inland near ocean.
So we have to give them weight.
No weight, not weight, because the classifier that we're using, can't use strings. So we'll be replacing them with an integer value. So nearby is 1. It's not weight. All of them carry equal weight. So if the ocean proximity is 1, then it is near bay. We are mapping ourselves. Create a dictionary out of it and map it and replace it in the column. Are you following what I'm saying? Shall I repeat it again?
We need to add one column where nearby value will replace with 1 and correspond accordingly.
I am asking to replace the column, not add, because our mod classifier will not does not run on string.
So in the house features only we have to just
Yes.
In the house feature itself, in the proximity, you have to change these values. Devish, you're following, right?
No, sir. Sorry.
Sorry.
Like my laptop is not working, so I am not able to do it.
Oh, okay. Cool. Fine.
What did you just told to make the dictionary? For the
No, for the sake of simplicity, I asked you to make a dictionary. Okay, maybe like iterate through it and define a word. If I'm making sense. Am I making sense actually?
but like how we will give this all the
See,
value
there
of
are two ways to do it. Either, I mean, you either replace it or write a lambda function to create another column for corresponding value to an integer. We write a lambda to create another column, which will add a column. If it is nearby, it will be 1. If it is island, it will be 2. If it is whatever, 3. So the value that it will be picked from your dictionary. So that's why I'm asking you to create a dictionary.
okay.
Create a ocean proximity underscore map. Ocean prox underscore map. So that would be a map value. And because these are, I mean, you can write a code and write a map for it, but we have 4 values, so just write it manually.
So we have to map each value.
Map it to a value in integer.
What we have to give from 0 to 1? Like
This could be any value, so it's to be unique across all the unique values. Give it 1, 2, 3, whatever. This is an interesting value. Underscore 1 at ocean. What does that mean?
something.
Oh, 1 hour to ocean. Nice. Okay. When you are doing this, you have to create you have to write in a code that your code itself serves as a report. So when you come back to it, like this is why I did it because classifier was not able to understand the string values. Yeah. These are not weights. It does not mean like because it's silent, so the weight is high. We are just mapping value so that our classifier can use it. Okay. Now write a lambda function. Either replace it. I mean, I would have replaced it, or if you want to create a separate column, like it's up to you.
I think we will replace.
Okay. So making changes in the house features directly. Nice. Okay.
I forgot the lambda function
Yeah,
reformation.
just Google it. Actually, lambda is also not needed. We have a dictionary, so you can directly use it. Don't use lambda. Just do a replace.
Replace.
Yeah, replace with the dictionary. Dot replace and ocean prox map. That's it.
Like from the pandas method.
No. Here itself, ocean proximity dot replace. Remove the equal to.
Oh, okay.
Replace with ocean whatever prox map.
No, pass the variable. We created the variable ocean prox max. Yeah, it will work.
Yeah. Okay. Just read the what do I say? House features.
House
column.
features.
Run it. Okay, it did not run. So you have to reassign it to the value. So house feature of ocean proximity is equal to house feature dot replace. Run it. Okay, now run house features again.
Hmm.
Okay, it has been replaced. Cool. Now run your classifier again. Okay, now run your fit. It's running.
It's running.
It's taking a lot of time. I think the data is bit too much. Okay. So did you guys understood like what we exactly did here? Any doubt, Nishan?
Yes, yes, we did understand.
Okay, awesome. Excuse me. Longer. At least we did not run into error. Write the prediction function. We will check it. It's still running. Did not run till now. It's 20,000 rows. So it'll be done.
Should I start
No, no, no. Wait for it.
instructor?
Sorry, did you stop?
No, I think
It's
should I
taking
restart the
time.
control?
No, it's taking time.
Did it run for you, Nishan? Nishan.
Yeah, it's taking time.
Even for you, it's taking time.
Yeah.
Okay, so let's keep it here and then we will do a prediction. So that will be testing. Like what are the factors that affect? I mean, in our common knowledge, like let's say a room size is big, there are more rooms, and let's say house, each of the house is less, then we know that the value of the house is a bit more. And also in my case, I've seen that median income does also affect. Let's say if the income is high for a particular household or a particular building, usually the rents are also high. We would put all this perspective of ours into picture and check if our prediction model is right or not. If it is near the ocean, then it would be expensive. It's in the island, then even more expensive probably. It's 1 hour away from the ocean, then it could be cheaper. A lot of factors does affect. Mhm. Cool. While this is happening, we will go to the theory part and let me know when it is done. Till then, what I'll do. Okay, we are dependent on this prediction model for the following. So what we'll do, I'll go to the conclusion of the lecture. We'll start with the theory part, and once that is done, we'll come back here. Okay, cool. I'll share my screen now. 1 second, guys. Is my screen visible? Is it visible?
Yes, yes.
Okay. As usual, I'll share the PDF after the lecture is over. So yeah, so let's get started. Machine learning problem solving step. Like, what are the steps in order to solve the problem? Now, in order to solve machine learning problem, we follow a structured approach that helps us ensure accuracy, clarity, and effectiveness. Here are the main steps involved. Look at the big picture. Understand the over problem that you are solving. Define your objective clearly, and what does the success look like? Okay, in our problem, which was the housing data prediction model, what we want to check, like we want to provide customer the value for money. What would be better? I mean, where they want to compromise. If you want a really big house, better you sort of like stay away from the bay, and maybe you'll get a bigger house for a cheaper price. Like for you, if whatever is necessary, so we will. That's the bigger picture. We will be providing value for money to our customer. So that's the bigger picture. Oh, just a second. I'll just put it here. Huh. Collect the data. We are already had our data. So in order to, let's say, collect our data, we can run scrapers. That's something that we learned previously. We can scrape to other websites. We can get it from the API endpoints. We can buy those data. We can get customers' data. So getting the data, this is something that you should automate it while you're building a model. This is more important. The better your data is, the better your prediction model is. Okay. Analyze and visualize the data to uncover patterns, trends, and anomalies. This helps you understand what you're working on. And when you visualize the data, when you explore the data, then you'll also get certain patterns, like what are the exponentially sort of like are dependent on the other data. Okay. The next part is prepare the data, clean the data. That's something that we have worked on for pandas, and in just right now that we did, we saw that in our model there was a string value nearby, so we cleaned our data. So that is one of the way to do it. This preparing data and clean data is something that is going to be a lot of time, because we will be getting the data. It could be null value. Let's say certain data which were previously before this, there was a schema change that those data were there. They are in different database, but now since you are running the model, you will have those data empty. So all of this has to be taken care of. So preparing the data and cleaning the data is one of the, what do I say, time consuming tasks. Then select a model and train it. Okay, choose a suitable machine learning algorithm and train it using. This is where your model learns from pattern. We just got to know that what models that we should be using. We had a flowchart. I'll share that with you as well. Currently, we are using a prediction, hence we are using a classifier. Okay. Next is fine tune a model. Okay, optimize hyperparameters, try different techniques, and try performance through iteration. In our case, we saw that maybe our model is taking a lot of time. If that was the case, what we'll do, we'll split our models into different threads and then run it so that it runs more efficiently. Behind the scene, the models does such thing, but there are certain ways we can fine tune our model. Let's say we saw that there are 5 columns, and because of which it is taking a lot of time. So we'll maybe break it down to 3 columns. We will make necessary changes. Just present your solution, explain your model's result using visual metrics and clear language, so stakeholder can understand and make decision. So this is where is sort of like matplotlib comes into picture, and you have to come up with a report of whatever the data and what is the conclusion of our data. The next one is launch, monitor, and maintain. Okay, there will be new data that will be coming through a pipeline across. For companies that has a lot of data every day, there could be 1 lakh rows or 2 lakh rows or a lot of rows that could come in. This can significantly change your prediction as well. Let's say your website was used by people above 30 and they had different approach on doing things. But now, after doing an extensive marketing, there are new users coming in who are like under 18 or 16. So their pattern would be different. So a model should be able to incorporate that, maybe all the changes. And yeah, these are the launch, monitor, and maintain part that we should look on. Okay, data set for machine learning. We know that these are the data set. Kaggle is something that I personally use. You can join competition, you can get the data set, and you can learn it. So something we also tried doing, like daily we will do a Kaggle problem, but that's something we could not do it. Then yeah, Scikit-learn. Okay, Scikit-learn, we already did it. random forest classifier, use the data. We separated the features and label. Always remember, in a classifier, you're already given the features and label, and you create a prediction model. So data is very important. It is dependent on the data that you are getting. How you train the model? This is how you train the model. Okay, the model is trained on your complete data set. Inference, okay, whatever is the prediction, predict on the same and the new data for what do I say? Demonstration. Okay. Then we come to evaluating performance, which is accuracy. That is something that we check next. We create a prediction model from our data itself. Then we are running the accuracy through it. We are giving the same input and we are testing the output, and then we are determining if it is true, then it is accurate. If it is false, it is not accurate. Usually it is total number of accurate data divided by the total number of data. So that is your accuracy percentage for the model. For it, correct prediction divided by total prediction. Okay. Okay, this was Gurgaon house. I mean, best day in Gurgaon. Okay, cool. Where is ocean? Okay, okay. See, we'll treat this as simulation purpose. Suppose the California data is Gurgaon data. We got it. So the housing price model that we are doing. So why are we building this? Okay, this is the objective of our model. Gurgaon is a rapidly growing city in India and has seen a sharp rise in real estate development over the past decade. With its proximity to Delhi, booming IT hubs and modern infrastructure, Gurgaon has become a major attraction for both home buyers and investors. However, the real estate market here is highly dynamic and often difficult to assess without proper data-driven tools. We are building a Gurgaon house price prediction model to help understand how factors like location, size, number of rooms, and amenities affect the property price in Gurgaon. So this is the reason why we are creating the model. We will be helping the buyers in identifying the fair price based on the historical trend. Okay, help sellers estimate an appropriate asking price, empower real estate agents and platforms to improve recommendation and negotiation. Okay, how are we building it? Got it, right? Why we are building it, and let's go to how are we building it. While we don't have access to large clean data set of house processing Gurgaon right now, we will use a well-known and clean data set, the California housing data set as proxy. This will allow us to build, test, and evaluate a working model with real data values like, okay, the column had medium income, the proximity to the city center, number of rooms. In our case, it was proximity to ocean, latitude and longitude, population density. We'll treat this as simulation. Suppose the California data in Gurgaon, and suppose we are building this model for a neighborhood where both you and I live or work nearby. Once the model is developed and understood, we can later adopt the same approach to real Gurgaon data when available, using the same techniques and logic. Okay. Before we build the model, we need to understand what kind of machine learning problem we are solving. First, we will check if it is supervised or unsupervised. Okay. Now, it's already written over there, but do you understand? It was a supervised learning model because we are giving them, like this is the data, this features, and this will label. Since we have historical data with house prices and we want to predict the price of a house based on input features, this is a supervised learning model problem. Sorry. Next, we observe that the model is predicting one continuous label, the price of a house, based on several input features. This makes it as a univariate regression problem. Okay. Got it. We have one continuous label, the price of the house, and based on several inputs, that makes it a regression problem. Okay. Let's do one thing. Just a second. Univariate linear regression, and why is it called regression? The main is to develop a model that helps us underlying relation between variables and reach of our survey. Okay, when it is a regression problem, when we are developing a model, the underlying relationship is define a data value between the variables and the outcome. So that is when you call it a regression model. So in our case, we had 4 features that was determining the value of the label, and hence we call it a univariate regression problem. Okay. Now next is did the model run already? Oh my god. For both of you.
I get error, memory error. I get
Yeah,
error of
same.
memory allocation.
Oh.
Allocation error. Memory allocation error.
Yeah.
Okay. So 20,000. What are your system specifications? Both of you?
Half TV.
Sorry?
60 GB
16 GB.
and 512.
Yeah,
Assistant.
same. SSD same.
Cool. If you didn't make any mistake. I don't know. Share your screen. If this is, we will start with measuring the error. Page number 10. Okay. Chris, if you can share your screen. Can't say it. Can't be my internet issue. I got an Ethernet cable, guys.
And his internet is not working.
Yes. Okay, Nishant, if you can share your screen.
Yeah.
You got the same error, right?
That is a memory error and
This is like I'm not able
not
to.
allocate these bytes.
Ah, maybe error. Crazy, man. Scroll up. Use random forest classifier, right?
Yeah.
And that's what we use. If it did not run on your system, then definitely will not run mine. Well, I'll,
Class server.
no, if it did not run on your system, even I have same specification. It probably will not run on my system either. What we'll do, we'll hire a, not hire, I'll, I'll take a GCP instance and we'll run our code there. Okay, cool. Stop sharing. I'll start sharing. We were able to. No, we can reduce the data and check, right? Yes. Nishant, please share your screen again. What we'll do, we'll reduce it to 2000 rows and then we'll run it. Scroll up, do a 2000 for what do I say, for data at the top. The top in line number 2, you should be able to do it. Column 2000. I think that should be it. In a square bracket, column 2000. Line number 2. No. That's square bracket. Outside it, square bracket, column 2000. It should move from 0 to 2000. Run it. 2000 that is. Now what is the problem? Sorry, memory error. What's the problem? I mean, I run all my models inside Databricks and like clusters which are very heavy. So I never run any prediction model in local. Nice.
While running, we only collected 2000 on that. We don't get Iceland data.
Island and all that we are not getting. So okay, just but line number 21 say there are nearby and whatever. Okay, then comment it. Island is not there, then it's commented. Run it again. Still, it's memory error. So
Yeah.
do it for 100. Go to the top, write 100 and do a run all. Go to run and click run all. At the top, in the menu bar, no, that will only run the cell in the menu bar. File, edit, view, run. That's the run button. At the top. Yep. File, run. Go to run. Click on run all cells. Yeah, run it. Oh, at least it ran, right? For 100 it ran. No, keep it to 100. Hey, you are testing now, like in the middle of class. It ran for 1,000. Nice.
4,000 running 4,000.
Oh, cool. Run the prediction. Devesh, are you understanding what we're doing? Devesh, you there?
Yes, sir. I'm
Okay. Put any value from this list. I mean, I'll give you the value. Hey, I don't have the values. Chris, can you give any value from your this thing? I think we lost Chris. There has been this norm in our lecture that at least one of us will have issue with our internet. You have to give that nearby ocean value. The ocean value. It's an integer. Okay. So the price, what is it? 2,46,900.
Yes.
Yeah. Go to that sheet. Let's see. The main sheet. Go to the main sheet. Near base 1, right? Okay.
Nearby 0, right?
0. Okay. Yeah, you
Give
gave
it
it 2. It's inland. So yeah, the pricing does make sense. So put 0 and check what's the price. It should be equal to what you have because that's from the model that we're using. It's same. Oh, what's the price? What's the price? 242,269. That is the price.
2,46,900.
And what is the real price?
I give the random data. I didn't give the any.
Oh, you give random data. Oh,
Yes,
I
yes,
thought,
yes.
then why were you going
No.
to the sheet?
I'm giving random data from the
Okay,
range.
no.
I just asking.
No, no.
I'm seeing the range.
Okay, no, just give the data, like put a data, like first you test the model, right? To test the accuracy.
Okay, so I give the. Okay.
Just copy the whole row, you'll get all the details.
It is giving
No
the
copy.
same answer, like the same.
Same,
price.
right? So yeah,
Yeah.
that's how you check it. I mean, like you're using a simple data set, it should not be complicated. I'll just leave it. Chris, did you do it?
Yes.
Yeah, can you share your screen? It's getting the same data answer as your data set, right?
Hmm.
So we have created a model. I think it's 1,000, so it's not very what do I say reliable. But for our use case, let's assume it is 1 lakh data set, and this is what you're getting. Now, let's say if you want to, let's do one thing. Let's give a random data. First we test it. First is you test the data. You test the accuracy. Like, is it at least passing my own test cases? You know, and you get the accuracy report from the test data. Okay. Now next, let's predict ourselves like how the prices should be. You know, prices if it is inland, same property. If it is nearby, the prices should increase, right? As per our knowledge. Okay. Just find an inland property and get its value.
Inland property.
Filter and all the ocean proximity. Go to filter. Can't. Maybe let me find it for you.
So here we have the inland.
There's no inland property.
Yeah.
Okay, inland. Take an inland property.
So we should have all this data, right?
Yeah, we need all the data. Copy it.
Not copy.
Can you do Control C?
Control C, Control C. Control C will work.
Yeah, it should work. To put comma and all that, yeah, it should be done work.
Okay, and
This is inland. What's the value of inland?
it's 5.
Okay, run it. Click on the prediction. Run the
5.
prediction. No, did you run it? Okay.
Yeah.
This is around 5 lakh. Now, see, there itself, same property, but change the value to 0 instead of 5. The price should increase as per our model.
Yeah.
Go to prediction. Okay, it did not change.
Hmm.
So in our model, the ocean proximity is not getting affected.
Yes. It is not getting affected.
So our model is not that reliable, I believe. Okay, change other value, change the household income.
Let's change this.
Put the household income to 0. Let's put an arbitrary value.
The household. This one column, right?
That's household median income. Sorry, median income. Let's put it to
1,000. Let's put it to
yeah. Put it to 0. It's not changing.
it is not changing. That's so now it changed.
Okay. So what was the column that was affected?
Our median house value.
Median house value is our label.
Yeah, that is also like it.
So that is not part of this prediction. The prediction, the columns that we are using, which is, I mean, may not be clear here, but we are only using columns of house features.
Okay. Because-
Cool. I think because we don't have a lot of data, maybe that's the reason it's not able to do it. But let's say if I'm preparing a model, I would put more weightage into certain columns. That's something we will learn next. Okay. Okay, let's get back to the theory and finish the theory today, and then we will continue from the next lecture. Okay. I'm sharing my screen. Okay, we understood the problem. Now next is measuring the error. After training a regression model, we need to evaluate how good it's our prediction. Two common metrics used are MAE and RMSE, which is mean absolute error and root mean squared error. These are the two mean metrics to determine the error in our model. MAE stands for mean absolute error. It calculates the average of absolute difference between the predicted and the actual value. Formula that is, which is 1 by n into sum of actual minus predicted value. Okay. It treats all error equally, no matter the size. MEA is based on Manhattan norm, also called as L1 norm, which measures the distance by summing the values. Okay. So how it is calculated? This is mean absolute error. You know, the actual value that you did, you ran through the test data, and the prediction of outcome that has come, it is you get the sum of it. Let's say there was an instance one, instance two, instance three. If I had a notebook, that would have been better. But if I can, let's say for one case, the actual value was 100, but the prediction value was 101. So difference is 1. Again, from for the other value, it is there was no difference, and we predicted the way it was in the test data. It is 0, and then for again it is 3. So we do a 1 plus 0 plus 3 divided by, in our case there was, let's say, 3 data divided by 3. So that would be your mean absolute error, and in our case it stands out to be I think 100%. So if you're understanding what I'm saying. Got it? Did you understand how it is calculated?
Yeah, yeah.
Okay. The second is, so that's why accuracy was more important. So that's why we were trying to get the accuracy of the result that we are doing. Okay. Second one is root mean squared error. Root mean squared error for root mean squared calculate the square root of the average of square difference between predicted and actual value. How it is done? We get square root of whatever that we have, actual minus predicted value. We do a square, get the sum of it, and you divide it by n, and the square root of the value is something will be your formula. RSME gives more weight to large error because it squares them. RMSE is based on Euclidean norm, which is called an L2 norm. So usually this is how we calculate L1 norm and L2 norm. Okay. When all errors should be treated equally, when large errors should be penalized more. Okay. This is something that you have to remember. Like when you want to use, I mean, when you are creating reports for your model, this is how you check for the error. Analyzing the data, okay, we will just skim through it. How do you get df.head, you get the first pyro, df.info, that be something we have learned already, you get all the summary. Df.describe will give you all the mathematical notation available, count, mean, standard deviation, minimum, 25%, 50%, 70% max, something that we have covered. Okay, you want to get the count of the values, df.column_name.value count is something, that's how you use it. Okay, now how do you creating a testing set? Usually, this is how you're creating a testing method. Okay, let's go to, we create a seed so that we can reproduce the same testing set, and we populate the data. Okay, let's understand. Okay, we get the numpy, there are random data, there is random subsize, then we are creating a test set. Okay, let's not get detail into this. Okay, there are certain ways. Maybe I'll go walk you through a code. Just give me a minute. Just a second, I'm sharing my screen. This is for a reference. Going forward, you may not have data set, but we will be creating, what do I say? Is my screen visible?
Yes.
It is, right? I'm not able to zoom in for some reason. Oh, now I'm able to. What we are doing, we are creating a random set of data in order to test our model. We created a seed. Okay, when you create a seed, it is easily reproducible in that way. You wanted 1,000 rows, and we are creating random integer, random choices, random integer. So these are the function that you can use. You create a column, then you convert this dictionary into a data frame, and that's it. You have your own sample data set. This is one of the way to do it. Okay. NumPy's random function is something that is going to be very helpful in creating the data set. Got it? Okay. Let's come back to, okay, strata is a subgroup defined by specified and then each of the cool. Not needed, not needed, not needed. Okay. Data visualization, that is something we did in matplotlib. Let's not go there. Correlation matrix. Okay, this is something. Handling missing data. We needed that housing data to work properly in order to do this. Okay, let's do one thing. I'll sort of take a cloud for rent, maybe a GCP or on Azure, and then we'll run this model, and then we will do this visualization and everything in the next lecture. Till then, let's keep it till then. Any question, Devesh, Nishant? No, right? Shall we connect tomorrow if that's okay with you guys? Morning, 8 to 10. I mean, I'll be available at that time. Okay, that's fine. Let's see you tomorrow, guys. I'll take a GCP or any other cloud computing system, and we'll run our housing prediction model by. Okay. See you guys. Thank you for your time. See you tomorrow. Bye.